Hello and welcome to the Advanced Topics of Azure Machine Learning course. In this video, we'll discuss using Visual Studio Code to schedule experiments on the cluster and using datasets and Jupyter notebooks inside Azure ML. So before I start, I want to point out that the material presented here is also available as the workshop, which you can find on the GitHub. And which contains all the steps you need to take to repeat the exercises I will be showing you here. Or it's also available as the blog post. So if you prefer reading, follow the link on the slide. Now let's start by creating the cluster in Azure ML, which we will need. We log into the Azure ML portal, and then you can see it contains a lot of different sections, and we will go to the compute section to create required compute. Here we'll go to compute clusters, say new, and put in some cluster name. In this case, I will just give it some name, Azure ML cluster. It will be, in our case, CPU cluster, but you can create GPUs. You can set it to low priority if you want cheaper option. And then choose the number of nodes. We will say between 0 and 2 nodes, and we'll click create. The good thing about having 0 nodes is that when you create a cluster, it would not spin up the virtual machines immediately. You will see that the count of nodes is currently 0. But as soon as we submit the experiment, the cluster will be automatically scaled up. And as soon as the experiment finishes, it would be scaled down. So you will not be paying for any additional resources that you are not using. So the way this typically works is that you work on your local machine, you prepare the training script, which is normally a Python script, and then you submit this experiment to run on the cluster. And this can be done using the CLI, using the commands presented here. All this can be done from Visual Studio Code very easily, and I will show you in a minute how this can be done. The big advantage of this is that you can also use logging from within the script. So if you want, for example, to log the accuracy of this experiment, you add a few lines of code to the script to record it inside Azure ML workspace. And when you submit experiment, what happens is that Azure ML takes all the files, packages them, creates a container, and deploys it on the cluster automatically, scaling the cluster if needed. So let's see now how I can submit the experiment from Visual Studio Code. Let me switch to my Visual Studio Code, where I have my Azure ML Starter GitHub repository open. And in this repository, there is a file called train universal. It's a very simple scikit-learn machine learning model to recognize handwritten digits from MNIST dataset. You probably would know about this very famous dataset. It's virtually impossible to go wrong with it, so it's very easy task. This script, I can run it locally in Visual Studio Code. I can select this text and then click Alt Enter, and you can see down below the script is executing. It is fetching MNIST data from the internet using OpenML dataset. So now it will download the data. Then it will take some time to do actual model training. And we'll see at the end we'll achieve some kind of accuracy, almost 90%, which is not bad for a logistic regression because that's the simplest possible model. So now suppose I want to run this on Azure ML and I want to log the experiment result. To this, I have a few lines of code in the script. First of all, this one, I check if I'm running on the cluster. If so, I can instantiate this run object. And this run object will allow me later in the end to log the accuracy and say run.log, and I record the accuracy. And that's all modifications I have to make to a simple Python script. Now, to run it on the cluster, I go to this file in the Visual Studio Code menu, right-click and say Azure ML run as experiment in Azure. In order to do that, I would have to have Azure ML extension and Azure account extensions installed in my Visual Studio. But once I have them, I just click and I configure, I do some selections using the menu. So first of all, let me start doing quick prompts because that's easier. It asks me, do I want to train remotely or locally? You can also train the same experiments locally, but record the results on Azure ML Workspace. However, I want to run on the cluster. That's why I select remotely. I select the Azure account. I select the existing Azure ML Workspace. I can also create the workspace from here. And then important thing, I can select the Azure ML experiment. So let me select, actually I will create a new experiment. Like this, X. Now it asks me which compute I want to run the experiment on. I will select Azure ML Compute, one of the compute clusters that I have without GPU, or I can create a new cluster from here. And then I need to create the run configuration. Run configuration is something which defines all the libraries that my script needs. So I will create a new run configuration. And here there are different options that I can use. For example, if I use PyTorch, I can specify PyTorch version here. If I use TensorFlow, I can specify TensorFlow, and it saves me a lot of manual configuration steps. In my case, I'm using scikit-learn, so I will use Azure ML scikit-learn. Then, if you are using any kind of data set, you can select the data set from here, but I am fetching data from internet, so I don't need any data sets. And you see, now I have the JSON file generated for me, which includes all the configuration of my experiment. It includes all the dependency libraries which are required. If I depend on some additional libraries, I can specify them here. I can also set any environment variables or whatever I want, the Python version and so on. And once this is done, I can click Submit Experiment, and the experiment is being submitted to Azure. What is important? It's important to include all libraries in the configuration, because if you missed something, the script might not run on the cluster, even though it runs locally, because locally you have all the libraries installed, but on the cluster it needs to configure the environment from scratch. So it is quite important to include everything you need. So it takes a little bit of time to submit the experiment to Azure ML. Once it has been submitted, we can go to the portal to check the results of the experiment. So here we click on View Experiment Run, and it can open the portal for me. Here we have the experiment on the portal. We can click here, and we can see initially the experiment is queued because the cluster needs to be scaled up. So it takes some time for the cluster to create the node. But meanwhile, you can check out the outputs plus logs section of the experiment, which contains everything that our experiment prints out, also including the steps for preparing the container. So eventually there would be some files here, and this 70 driver is the most important one because it contains whatever our script prints out. Here is fetching MNIST data is something which my Python code is printing. So we can see that the script is now working. And if we wait a little bit, we will see the results of the execution. Here we go. The 0.855 is the achieved accuracy. And because we log this accuracy, we can go to metrics and we can observe the result of the experiment. Here is this result logged inside the portal. We can also see it here in the diagram as well. So now if you want to perform several experiments, you can do that, and all of them would log the results, and it would be easy to compare those results on the portal. So normally the way you would work is you would make some modifications to the code, submit the experiment, and then see if it's getting better or not. So what is important is, as I mentioned, to have all the library versions correctly set up in the JSON config file. If you don't, the best way you can see that something went wrong is by checking the script output. It would print you if it depends on some library and this library is missing. So you would be able to tweak the configuration and make it work. Normally, it takes a little bit of efforts to make the script work the first time, but then once you do, it's very easy to perform further experimentation. So let's see what happens behind the scenes in more detail. When I edit the script on my computer, it can be the computer without any Python environment installed, or it can be not a powerful computer at all. I just prepare my Python code there. And once I submit the experiment, all the current folder is captured and it is sent to Azure ML. The reason I need the whole current folder is that normally with my Python file, I can have some additional libraries, and it's very easy to include them as well. So Azure ML then prepares the container based on my files and stores it in some repository for Docker containers inside Azure ML workspace. Then it distributes this Docker image to the compute cluster. And if I'm using some data sets, it also mounts the data store. And this is very important because normally, like if I want to train somewhere else, I would need to get the data to that location. I need to copy the files. But here, I don't even copy the files. If I store the files in the data store or data set inside the workspace, it just mounts this resource to the cluster without any data copying. So that's very fast and very efficient operation. So then I'm ready to train. I launch the script, and all the outputs of the script are logged together with the experiment. And you can always come back to them later and see what was right and what is wrong during your script execution. You can also stream those logs directly to your computer in real time if you want, but you can also check them on the portal as I have shown you before. Finally, once you've done training the model, it also captures the output of your script. If you produce any outputs in the special outputs directory, it takes all of that and records it together with the experiment in the common repository. So that's how we normally run training on the cluster. The way I showed you, the script I showed you has one drawback because it fetched the dataset directly from the internet and not from the data store. So ideally, if I want to repeat the experiment many times, I need to get my data into the data store. And I can do it manually through the portal. I can define the dataset there, but I can also upload the dataset from the Python script. To do that, we would need a way to run a Python script, and I will show you how to do it inside Azure ML portal on the next video. So in this video, we have learned that it's very easy to use Azure ML to submit experiments to the cluster from Visual Studio Code. That's the simplest way to start using Azure ML, and I definitely recommend you to try it out. To begin with, you can use the GitHub starter code, clone the repository, and try to repeat the example that I have shown you in this video, and then maybe try to train some of your own models using Azure ML. It can be a little bit non-trivial in the beginning, but once you learn how to do it, you will understand benefits. So I'm looking forward to see you in the next video and have the great time experimenting with Azure ML.